I'm here to talk to you today about some of the new features coming out in Cassandra 2.0. Can I ask how many people are familiar with Cassandra? So we've got kind of a smattering. And how many people kind of just wanted to know what Cassandra is and does? So kind of a handful there as well. Okay, cool. So, 2 slides. My name's Adam HATTRELL. I originally started in data with, actually I think originally it was a product called Superbase, which was a PC-based database product. I then moved to Informix, which is a kind of traditional RDBMS. We were bought by IBM, and then I've kind of worked with a number of different data managing products, including this thing called Infosphere Mashup Hub, which I'm pretty certain was a marketing bet. I don't see why anyone would name something that silly in kind of reality. Finally, I moved out of IBM, joined Splunk, where I helped support some of their enterprise level customers, so people like Credit Suisse and Barclays and those kind of people who are crunching a lot of financial data. And then I was approached to join DataStax to help form up their support offering in Europe. I was kind of the first support feet on the ground. And it's been absolutely mad since. We seem to have a whole bundle of customers who wanted the Cassandra support, but didn't really want to wait on that round time trip to the US. So now that we're here, they're kind of signing up in droves. So to touch on the bit that we were talking about earlier, what does Cassandra do? How do we use it? I'm kind of a tech guy, so I don't really like the marketing kind of side of all the products, but I was forced to put at least one slide in with some of it. So this is the kind of the favorite graph that they like to throw out there. Cassandra is very, very, very good at mass inserts at velocity. So lots and lots and lots of data go in. And most of the optimizations are about making sure that speed is maintained. The select side, the read side, is still fast, but you know that whenever you prioritize something in one area, you always get trade-offs. So, and that will come into play later. But so this was an independent survey of some description, and as the number of nodes grow, we kind of scale linearly. HBase, I believe, also scales linearly, but is kind of slightly less, allegedly. So anyway, what am I going to talk to you about? There's kind of 4 new features in 2.0 that are of most interest, typically. We've implemented what they call lightweight transactions. It's basically check and set. It uses something called Paxos as a kind of model of approach to do that. We'll talk through that in quite a lot more detail. We'll also talk about this triggers feature that a couple of our larger customers wanted, so that's being looked at. That's very experimental at the moment. I wouldn't want to build a kind of enterprise offering around that at the moment, but it's there so that you can see how it would work in the future. There's some compaction improvements, which once again we'll kind of talk about in more detail. We've added CQL cursors to allow you to page data as you're reading it back. That gives some significant improvements in performance. And I'll talk a little bit about kind of the new native driver approach. Traditional Cassandra uses a model thrift, whereas we're now looking at a direct Java kind of access interface, which should, once again, it should give us better performance. So one of the kind of, it's a common problem for this use case is I have 2 different servers, I've got 2 different users coming in, I've got a website, I want to give myself a username. How do I ensure that the username that I've got isn't taken by someone else during the process whilst I'm committing my data. And the way that historically that kind of insert would work is if the second insert comes in just a couple of fractions of a microsecond later, it'll overwrite. And so I've got this problem now where the guy on the left thinks that he's got his account and he's happy, but actually the guy on the right has overridden it with that email address, and now everything's going through that user. So here's how we do it. The first thing we have to do is get people's attention. This is the method Jack Nicholson uses, kind of stick your head through a door. I tried this with a manager once to try and get a pay rise. It really doesn't work. But for this kind of scenario, it's actually pretty good. So what we do is the guy who's coordinating, or should I say the guy who has an insert that he wants to run, he will send out the current time as a UUID and the name of the value that he wants to change to all of the nodes. I say all of the nodes. Technically, it's all of the nodes that we're replicating to. So we have what's called a replication factor, which is how many copies of your data you want to keep. So we will identify which nodes are responsible for that particular data, and we will request them to say, I would like to update this, and this is the time I want to do it. If another node is simultaneously sending, then what basically happens is the person who is sending latest gets to win, but we're looking for a quorum of nodes to respond to say, yeah, I'm happy with that request. So if I've got 3 nodes, then 2 need to respond to say, yep, I'm willing to go ahead with this. If I've got replication factor of 2, then I need both nodes to come back. So you need to think this through if you're going to use this scenario. If I've got 1 node, then I guess you're kind of asking why you're using check and set in the first place, but I guess there may be use cases. If 2 of my nodes are attempting to send at the same time, and there's a network issue, it basically determines, the middle node is the guy who's going to get to make that decision and say, yep, this guy's good or that guy's bad. The other thing we do is we always respond with the highest request I've seen so far, and that might mean a do-over. So if I come back and say, oh, okay, this guy has requested a higher value, so I've got to allow him to continue, and then I'll wait until that's completed. After that, we go to, actually, technically, there's another step. So once I've got agreement from a majority of nodes that I can start doing this piece of work, the very first thing I do is check the data on disk. If the data has changed and someone's already got that data, there's no point in me continuing. So at that point, we'll then abort the whole process and we'll return a failure back to the client. If I can't get a quorum of nodes, same thing happens. I'll immediately reply back to the client to say, sorry, there isn't enough nodes available at the moment. Try again later. I'm sure everything will be fine once your network stops playing up. So then we go into a second round. This time we give the time UID again, the key, the value that we want to change it to, and we send that to all nodes. The reason for having the second round is what happens if my server crashes after I've done the initial. So I've got my prepare, I've got my promise, but then my node who's coordinating dies in state. The client is rerouted to another node. Someone else is going to have to pick up that mess. But then potentially, the network comes back up. Flapping happens reasonably common on EC2 if you're not careful. So then I've got 2 people who are trying to commit the same information, and we need a way of determining that. So that's why we have a second round. In the second round, I give you my time UID, key, value. Once again, the latest time UID wins, and we get a kind of vote. And assuming enough people say they're going to commit, we can then proceed on to the commit and ACK. It's based on the old agile joke, you know, when you make breakfast, who's committed and who's involved. The chicken's involved, the pig's committed. So this is the final round. We get in theory, enough nodes can then commit. Any nodes that are restarting, once again, they have a method that they can come in and say, where are we up to, what's the current situation? And then in theory, our data is written, and we're good to move on. So that basically leads to, on a success, 4 round trips for a read. So I have to read 4 times before I can write my data. So there's a reasonably significant overhead here. And worse than that, that's assuming a completely successful. I've got no network problems, I've got no node failures or anything like that. So I've been able to run it through 4 reads, then I can do my write. If I'm doing this if I'm trying to use this as a kind of transaction mechanism similar to ACID, you're going to hit some performance issues there. So this is really for the kind of 1% of cases where you need to check something and then you continue independently. So for example, you could use it to latch something and then have people checking the latch, but they basically run through their batch without kind of checking every single individual result. Or at least that's the goal. So have I really missed the... No. Can I go back, please? Yeah, I've lost the slide. Okay. So the actual syntax is insert into blah if value exists. So you can check for a specific value or you can check for a null. So the next section is triggers. As I said, this is experimental in 2.0. It's kind of a beta release, really. Syntax is reasonably straightforward. Create trigger name on table using class name. You have to write your class that you're, to carry out the transaction or whatever it is you're doing, your insert, your update, your delete. I believe one of our customers is considering using this for a kind of stored procedure type approach. I'm not sure I'd recommend that. A lot of what, as I said, the kind of key value for Cassandra is your ability to kind of pump data in as fast as possible. Triggers is going to have an impact on that. So I would be very careful in how I introduce this and what I use it for. But that said, I think in very specific cases, it probably could be quite useful. So compaction. When Cassandra writes to disk, when you insert some data into Cassandra, we first of all write it into a mem table. It's also placed in the log so that you don't lose any data. Those mem tables are then flushed down to disk on a periodic basis, generally based on size, but occasionally based on system resources or that sort of thing. And that creates what we call SS tables on disk, which are a kind of ordered listing of your data per column family. We have currently two types of compaction. So there's size-tiered compaction and leveled compaction. Size-tiered works by whenever you have, by default, 4 SS tables that are of similar size, we merge them together. That allows us to remove any duplication. It allows us to potentially remove any tombstones that are outstanding, and also means that my file accesses are kept to a reasonable kind of level. Size tiered is very good for writes, but it can lead to a significant number of reads if my data's spread out. So we came up with something called leveled compaction. Leveled compaction works by you write your data to level 0. And then over time, it's compacted into subsequent lower levels that guarantee that each SS table contains the information for just one or a set of keys, a range of keys. And whenever we don't have enough space on a particular level, we basically push that range down to the next level and maybe separate them out into separate tables. The idea being that you'll only ever have to access, at most, the number of levels in file accesses. So this is kind of a healthy compaction. We've got level 0. We can gradually push this stuff down. Unfortunately, we do see the scenario where if you're doing a massive writes, generally on a kind of intermittent basis, so it's bursty, and you've sized your system for kind of the average rather than the max, you can end up with an absolute massive level 0s, and the compaction hasn't managed to keep up. So it's not managing to push it down to the lower levels in a reasonable time frame. I mean, it'll eventually catch up because the load will come back down to normal level, right? But we're kind of stuck in the meantime. I saw a customer just last week who had something like 42 accesses, and then went down to kind of 4 during his normal run, and that adds a certain amount of latency to your requests. I think he was going from something like 0.1 milliseconds up to kind of 5 milliseconds, which doesn't sound like a lot, but for him it was a big deal. So anyway, so we have this new approach where we kind of have done a hybrid. So as the level 0s are written down, we use the sizing model. So every time we get 4 or more SS tables at level 0, we'll mash them together. And then over time, those can be migrated down into the lower levels as per the normal kind of size-tiered approach. In theory, this should once again give us much, much better kind of throughput on the query side. Size-tiered is pretty intensive on the disks, so you do need to kind of bear that in mind as you're running. And there is another kind of model yet again that people are considering. So 2.1 probably there'll be yet another compaction model that we can use. The other feature that actually isn't covered in here but is part of some of the same changes is we have a new streaming model in 2.0. Mainly this was is for repairs. Currently, when you're running a repair which syncs all your data across the various nodes, it basically works by firing a JMX command to a node to say begin a repair, and that node will then start shuffling its data around. In theory, network problems can lead to us losing the kind of update that says do this repair and stream these tables over and let us actually compare them. And so we have had a number of situations where under heavy network load, repairs can just hang and appear not to go anywhere. So the new streaming model allows a kind of staging. So it keeps track of where it's at. There's a kind of master system table that now monitors the streaming process, and you can kind of ask for updates. You can tell it to redo a particular section. So this should improve things quite a lot. We also have CQL cursors now. So let's say I've got a table, just kind of storing tweets or something, and I want to know about specific data, but I don't really want to select across a kind of terabyte of data, pull it all back at once. Not least because my network guys are then going to scream down my ear about what the hell are you doing to my network. So currently you have to use this kind of format in CQL where you kind of do a last key and keep track of where you got up to, and then request the next 100 lines, and kind of pull it across. So now we've added a kind of AutoPaging function in the native. You do a select from your timeline. We will pull back 5,000 rows. You can configure the number of rows, you can't configure the size. But there's a query options here that allows you to query that fetch size. Obviously, if your rows are extremely large, you probably want to pull back less than 5,000. If your rows are really quite tiny, then bulking that up can be quite effective at ramping up your throughput. You can, so there's an iterator typically on the select. That allows you to request the next row, so it'll be reading from the page, and then when it gets to kind of 10% of the end of that page, it'll pull the next page for you. So this makes these kind of queries a lot easier. So the next feature I wanted to talk about was native drivers. So Thrift is a pretty comprehensive interface for querying, well, for communication basically. However, it's not, because it's generic, there's overheads associated with that. So our model works reasonably well. It's pretty stable. It's been going for quite a few years. And so there's lots of optimizations, but we are kind of hitting the limits of what we can do. So the idea was to have a native Java-based protocol on the server side, which they've based on Netty, and we can then write various clients in Java currently, C++, C#. There are plans for PHP, and probably any other. Python is just about out. Yeah, and any other language you care to name, there's a framework. It's open source, so people can generate their own if they so desire. So the other advantage is it's asynchronous. So Thrift, you can only really have one query per connection, so that can bottleneck you slightly. We're able to open one connection and then pump as many as we want down the line. And the other thing is it's because the server can push information back, it allows your clients to be situationally aware. So if a node is down or is experiencing heavy traffic, the client can be told and it can query different nodes instead. So that gives us some significant benefits. The current release, I believe, is on average about 10% faster than Thrift. Does depend on the particular situations. But they have a number of optimizations that they're expecting to make, so we do expect to push that improvement up, hopefully significantly. So these are examples from the Java driver. To form a connection, I specify a cluster that I wish to connect to. I can give it just one node, it'll interrogate that node, and it'll find out about the other nodes in the ring. So I don't have to necessarily tell it about all the nodes up front. All I have to guarantee is that my node is available. You can then, you can pull back cluster metadata. You can then build prepared statements or insert queries and fire them off using that cluster. So there's a kind of a common scenario there. And you can also do kind of the usual kind of selects and inserts, etc., that you'd kind of expect. It's a more natural interface to me, anyway. Coming from a Java background, it's kind of something I'm more used to. And there are plans to roll that up into a proper JDBC layer in the next quarter or so, which should also give us some useful kind of tooling. So I seem to have underrun by quite a lot. Does anyone have any questions they'd like to ask?
Do we have any questions?
Hi. There are a lot of NoSQL databases in the market.
Mm-hmm.
We have been working with some of them. But do you think, is it possible, because we have been talking about combining technologies, maybe a SQL database with a NoSQL database in a project or in a product, but do you think sometimes is it possible also or convenient to work with two NoSQL databases in the same project, because one of them is doing something very specific like graphics or something like this, as we talked yesterday, or any scenario similar to this? What do you think about that?
Sorry, so you're saying, does it make sense at a business operations level to have multiple NoSQL products in production?
Yeah, for the same process or project.
For the same process or project? Potentially. One of the things that we do in DataStax is we have an embedded Solar option. So people will run Cassandra for their kind of updates and their kind of transactional business kind of model. And then they will have the data automatically replicated to an equivalent Solar cluster, where you can then do the more traditional text search or interrogation of your data using that mechanism. At a non-embedded level, it kind of depends how big your data is, really. I mean, if I'm storing terabytes upon terabytes of data, petabytes even, the cost of migrating between two systems is going to be potentially painful, right? I do think the kind of focus is going to move towards interrogating your data in one particular place, because the cost associated with moving it become incredibly high. Does that answer your question? Or?
Yeah, more or less. Well, I think in fact you are using also with Cassandra Lucene, or well, it's not exactly another NoSQL, but yeah, you are combining technologies there. Anyway, other question is, really Cassandra is really very powerful. Congratulations about that, because the throughput is really amazing, and we recommend anyone to try it and to test it and so on. But it's a bit complex to start using it. Maybe if you compare it with Mongo, Mongo is pretty easy. Maybe it's not so powerful. Or and then how to start with Cassandra? Is there any facility, white papers, anything to help anyone to start?
So a lot of the focus in the recent releases has been to try and make usability easier. So CQL, for example, is one of those kind of factors where the goal is to give people an interface that they're used to. So rather than kind of key value stores, which is pretty good for programmers, but not so hot for people who come from a database background. And that provides a mapping into the underlying systems. So that's kind of one side. The certainly DataStax is recruiting heavily the kind of docs team to try and help provide more information. So datastax.com certainly has a certain amount there. And we've also started the what they call the DataStax Academy program, which is an online training it's free. You just kind of register, and we'll give you information about running through simple test cases or kind of setting it up. So if you haven't looked at Cassandra, then I would certainly encourage you to take a look at that academy. It's pretty good so far, and they're working on improving it to make it more what's the word I'm after? Kind of exercise-based rather than kind of info dump, which I think is always important in training.
Thank you.
Hi, I have a question. I would like to know your opinion about using Cassandra in virtual environments, such as a private cloud, in which you can have bottlenecks, such as the storage. Do you think Cassandra is still an option in that scenario?
So, sorry, could I? What was the? You said private cloud, but you have bottlenecks. What, in disk or?
Yes, let's say the storage. You have like a NAS that they are all sharing. Do you think you can still make the most of Cassandra, or in that case, Cassandra is not a good candidate?
NAS is problematic, I'd say, across most data. It can be done. You can set up your NAS array to give you the kind of I/O, the IOPS that you need. And I have seen systems where that's done, but certainly a lot of the principle of NAS is let's keep it as cheap as possible, and we'll just kind of throw stuff at it. Even going back to Oracle, I've had problems there with NAS. It's doable, but it does require a lot more work. You do have to make sure that you're not flooding the underlying subsystems. The problem is that things like Cassandra or Splunk or whatever, they're designed to just ram as much through as possible. So if I'm sharing that with, I don't know, the print manager or the file system shares and that sort of thing, I'm probably going to overwhelm your capabilities. So, you do have to be quite careful about it. I would normally, I would always kind of say locally attached disk is usually better for database products. That would be my kind of opinion, unless you're willing to put the time and effort in, and that is a reasonable operation. You need good storage guys to get that working.
Thank you.
Do we have any more questions? Yeah, one here.
Yes, I wanted to know if it's suitable for analytics in batch processing. So not just for finding something very fast, but going through the entire data set with MapReduce for machine learning and this kind of thing.
No.
No.
Well, not natively. Cassandra is really about that. That kind of, I want to store a lot of stuff and I want to be able to pull it out quickly in individual. So probably the easiest to give you an example. So the use cases are people like Netflix who store all the information about you as a user on Cassandra. So when you come back in, they want to be able to show you the last 5 movies you watched, the place you were at in those movies, and allow you to quickly get back into your kind of experience. The kind of batch analytics processing, Hadoop is kind of better place for that. So DataStax does have a Hadoop extension. So it's kind of a glue that plugs the two together. So you can do you can do some processing there, storing your data. Once again, like the solar thing, we can we can migrate the data between clusters to ensure that they're synced, and then you can do your processing on this one and push it over there. But if you're doing really, really significant processing, I would probably use Hortonworks or Cloudera or whatever to do that.
Yeah, that's what we are doing now, but I just wanted to know if we want to have people querying these results in real time, so we need a different system, or is there a solution that combines both things?
So you can do some data modeling stuff, regular kind of roll-ups of specific data, insert them into particular tables to ensure that you know what you've already got and is already in a format that you can pull it out. But doing, when I think of analytics, I'm thinking of someone who doesn't necessarily know up front, I've got a body of data and I need to process it. And Cassandra isn't really designed for that scenario. It's more designed for I know what I'm doing up front, I've generated my data in this model, and I'm going to make sure that I ram that through as quickly as possible. Does that make sense?
Yes, okay,
Yeah.
Thank you.
Okay, we have time for one last question. If somebody wants to ask something else. Nobody? Okay,
Nope.
over there. Last question.
In the sense of the last question, I just want to comment that there is a project, Apache Gora, that connects Hadoop with Cassandra. Although, as you comment, Cassandra is not prepared for that type of work. Is there some idea about creating a hybrid Cassandra with Hadoop in the sense of HBase that have slaves on each tracker node and the like?
As I said, DataStax does have something that does that. So they have a Hadoop offering. It's not currently open source, so sadly you have to buy it from us. And it works by sharing job trackers and task trackers around the ring. And there's a little bit similar to the Paxos stuff. There's a kind of election process where one node will be responsible for job tracking. But as I said, given the nature of the underlying subsystem, you're trying to use something that's designed for one thing to do something else. So there's an inherent pull there. So as I said, there are particular use cases at what I'd call the lower level kind of batch processing, where it's so if you want to just insert all my data. Let's say Netflix is probably an example. So they're storing all the films that you watched over the last however long. If I wanted to get metrics on how often a particular user uses a particular set of kind of movies, that's possibly a reasonable case, because I'm not necessarily going to be doing vast amounts of aggregation. I'm just going to do a little bit of summing. So those kind of use cases work, but as I said, if you're massing up into the kind of big joins, big groups, big sorts associated with my data, then that's not, as I said, it's not really the use case we're designed for.
Thank you.
Okay, thank you very much, Adam.
Thank you.